Designing Azure Virtual Desktop, or AVD, for a small environment is one thing, right? You can make a few rough assumptions, add a bit of headroom. Most of the time, it'll still work reasonably well. But once you move into enterprise scale, and especially once you start talking about an environment serving around, over 1,000 users, that approach stops working quite quickly. At a point, every design decision starts to matter. Okay, if your hostful strategy is wrong, your entire scaling model becomes inefficient. If your session hosts are sized around guesswork instead of actual workload data, you either burn money unnecessarily or create performance bottlenecks that affect hundreds of people at once. If your profile design uses too much dependency on storage performance, logons become inconsistent and troubleshooting gets really painful. And if you don't think about operational management early, the environment might look fine at sort of deployment and then deteriorate steadily as complexity builds over time. That's really the key point of this entire video. At enterprise scale, AVD is not just something you deploy. It's something you architect as a service, and the quality of that service is almost entirely determined by the decisions you make before the user even signs in. The most important mindset shift when designing AVD for scale is understanding that you're not simply delivering desktops. What you're actually building is a cloud-hosted end-user computing platform. It needs to be capable of handling changes in demand throughout the day. It needs to maintain a consistent user experience across hosts and sessions. It needs to remain secure and governable. And it needs to do all that without becoming operationally expensive to run. Again, there's loads of documentation around this, right? And it's all made very clear about this shared responsibility, right? Microsoft manages the control plane of AVD, but customers, we are responsible. The consumer, we're responsible for the session host, the user access configuration, storage choices, identity design, scaling behavior, and everything that surrounds day-to-day operations of that service. That means that AVD gives you a flexible framework, but it does not protect you from poor architecture. If anything, flexibility increases the importance of good design, because the platform will happily support design that is either elegant or inefficient, depending on how you build it. So the right way to think about AVD at this scale is not what do I need to deploy, it's what kind of service am I trying to run and how will it behave under load? How will it operate in 6 months after go live? That change in perspective is what separates a stable enterprise design from an environment that looks really good in diagrams, right? But it becomes difficult and expensive in practice. One of the most common mistakes in large AVD projects is starting with the infrastructure instead of starting with the workload. People jump straight into questions like which VM series to use, how many hosts to deploy, or which region to place them in. Those are all important decisions, but they are sort of downstream decisions. The first thing you really need to understand is how your users actually behave, right? When we're talking like in the thousands of users, you're almost never dealing with one single workload pattern. Okay, some users are light, highly predictable, and spend most of their day in a browser and Microsoft 365 applications. Others will have more variable application usage, more memory pressure, more CPU demand, or even different expectations around responsiveness. Okay, these are what we call user personas. Some users log in early and stay connected all day. Others create bursty patterns around shifts, when shifts start or operational windows. If you ignore those differences and design one generic AVD environment for all of them, then your architecture becomes a compromise before it even reaches production. This is not one ring to fit them all, right? It's not like that. This is why most sort of hostful strategy matters so much. The goal is not to create artificial complexity. The goal is to separate workloads that behave differently so that sizing, scaling, and management policies can be aligned to each group properly. If you mix every user type into a single host pool, you usually end up designing for the most demanding subset, right? And this causes everyone else to be over-provisioned. That impacts cost immediately. Also affects how well autoscale works and how reliable you can predict performance. So the right starting point is always workload segmentation, or user personas as I like to call it. You want to understand where users are similar enough to share capacity and where they're different enough to justify separate pools. Once you do that, the rest of the architecture becomes much more rational. One of the biggest reasons AVD environments become expensive is that teams focus too heavily on VM size and not heavily enough on user density. The question is rarely just what VM should I use? The more important question is how many sessions can I run on the VM while still delivering the right experience? That distinction matters, right? Because cost in AVD is strongly influenced by how efficiently you consolidate demand. Again, AVD cost guidance makes it very clear that session host VMs are usually the largest infrastructure cost component in the environment. And look, if that is true, and it usually is, then your ability to control the total host count becomes one of the most important economic levers in the entire architecture. The danger is that many design decisions are built around fear. Okay, teams normally choose larger SKUs just in case, right? They apply conservative session limits and assume that lower density equals better experience. Sometimes that does protect performance, but it very often just creates underutilized infrastructure. When we're talking like thousands of users, even a modest density improvement can reduce the required VM footprint significantly. That does not just lower costs, right? It also reduces the number of hosts you need to patch, monitoring as well, and operational management. The correct way to approach sizing is to treat density as something that you must be validated with real workload behavior. You start with baseline hypotheses, right? But you do not assume it's accurate. You test against real applications, real user patterns, and peak concurrency. Behavior as well. And then you adjust the design. That process matters because the wrong sort of density assumptions doesn't just affect one VM, it affects every scaling decision, every cost model, and every operational process built on top of the host pools. Autoscale is one of the biggest advantages of AVD, but it only creates value when the underlying design is coherent. A lot of environments technically have autoscale enabled, but the scaling logic just doesn't reflect the actual behavior of users. So the result is either wasted cost or poor user experience. God forbid, sometimes both, right? The guidance that we see around autoscale explains that AVD can scale hosts according to schedules and different phases. Again, I'll give an example of those in my other videos, like ramp up, peak, ramp down, and off peak. That sounds simple, but the design challenge sits underneath it, right? You have to understand when users actually arrive, how quickly demand increases, how much sort of pre-warm capacity is needed before peak starts, and how aggressively hosts can be drained and deallocated afterwards. You also need to understand how your sort of max session limit and load distribution behavior influences the point at which new hosts are required. Again, Microsoft does explicitly state that pooled host pools using autoscale need to be configured, right? And they need the max session limit being configured as well. And it warns against relying on the defaults. It tells you immediately that session density is separable, right, from scaling model. What tends to go wrong is that scaling plans are configured as if they were just a scheduling tool, right? People set times, add a threshold and assume, there's that word again, the problem is solved. But if the morning ramp up starts too late, the environment feels slow when users first connect. If ramp down is too conservative, the service runs excess compute well into low demand windows. If the host pool design is already too mixed, the autoscale plan has no clean workload pattern to optimize around. So the real design question is not whether autoscale is enabled. That's not the design question. That should be automatic. It's whether the autoscale model has been built around real sort of concurrency and log-on behavior. When we're talking thousands of users, okay, poor scaling logic becomes very visible very quickly. Okay, a small sort of mismatch in assumptions that would be barely noticeable at maybe 50 users can turn into a major experience issue or a major cost issue at enterprise scale. If you want more content at this level, actual Azure and AVD architecture thinking rather than just generic sort of setup advice, make sure you subscribe to my channel. I'm kind of building this around, those environments and how they really behave once you move beyond the lab and into production. And I really appreciate everyone's support. Another major design area that people tend to underestimate is user profile handling. At smaller scale, profile problems can feel annoying but manageable. We're talking thousands of users, they become a platform dependency. Again, FS Logic's profile containers is what's recommended for AVD because it allows for full Windows user profile to be stored in a container and attached dynamically at sign-in. And this makes Pool sessional architectures practical because users can connect to a different host without losing their profile state. Okay, it's also got performance benefits. FS Logic's it's important for sort of scenarios like if you have Outlook cache mode and OneDrive is sort of non-persistent environments as well. And this reinforces the point that profile handling is not an optional background plumbing, very central to the user experience. Okay, we're talking about architectural implications of that. It's very, very important. It can't be underestimated. Once profiles live like this way, your user experience becomes strongly dependent on the quality and consistency of your storage platform and your profile lifecycle management, right? The recommendation, obviously, for AVD is Azure Files or Azure NetApp Files for those sort of profile containers. This tells you two things straight away, straight off the bat. First, storage performance does really matter. And second, profile storage is a design decision in its own right, not an afterthought. At scale, this dependency affects more than sort of log-on performance. It affects how reliable users roam between hosts, how quickly sessions stabilize after signing, how profile growth impacts ongoing storage costs, and how easy the environment is to troubleshoot when something goes wrong. I'm an AVD architect, so I can say this, right? So sometimes we treat FSLogix as a solve checkbox only because the vendor, in this case Microsoft, has recommended it. But the truth is that the quality of your overall service still depends heavily on how cleanly you've designed the profile storage layer that sits around it. Identity is another area that often suffers because teams treat it as something that already exists rather than something that needs deliberate architectural thought. In practice, identity choices directly affect complexity, security posture obviously, and even cost, believe it or not. Again, what Microsoft tells us is that the identity provider model can change the charge components in that environment. We know Entra ID is one way of doing it, and that's sort of based around the licensing, so the cost is quite predictable. Because but if it relies on sort of additional directory services, the supporting infrastructure footprint changes accordingly. That immediately tells you that identity is not just a login mechanism in AVD. It's actually part of the service architecture and part of the economic model around it. From a design perspective, right, the real question is how much identity complex the environment generally needs. If the platform carries legacy dependencies that are no longer required, then the architectural debt appears not only in operational overhead, but also in the Azure footprint behind the solution. At the same time, though, security recommendations from Microsoft again are very clear, right? We as consumers, we are responsible for enforcing the appropriate access controls. I've mentioned MFA or multi-factor authentication before. I've mentioned conditional access as well, and securing the session host configuration. This actually means identity is also one of the most important security boundaries. AVD effectively extends access into your environment. So identity cannot be treated as a background prerequisite. It needs to be first class part of the design. Network is one of the areas where architects often overcomplicate AVD, right? Start building highly segmented or elaborate sort of designs long before they've even proven that the workload needs them. At scale, I'm talking thousands of users in this video, that can become a massive problem because complexity often increases operational fragility faster than it actually increases value. The most important networking consideration in AVD are usually not exotic, right? Things like ensuring that the region selection aligns to user location and latency expectations, making sure user session hosts can have reliable reach as well, make sure they can reach services and storage they depend on, and avoiding unnecessary routing or dependency chains that make troubleshooting really, really hard. Even though AVD abstracts part of the remote desktop connectivity model through that managed service, your session will still depend on the quality of the network environment they sit in. And profile storage as well as identity access patterns, they still require consistent network behavior. So the design goal here is usually not the sort of most advanced network topology. It is a topology that is simple, predictable, and resilient enough to support service without introducing unnecessarily operational weight. Right, let's bring this to a close now, okay? Let's finish off this circle. The final layer, and one of the most important, is operations. It's probably the biggest difference between a design that looks good in principle and a design that continues to work over time. An AVD environment serving, thousands and thousands of users is not something you can run comfortably through an ad hoc process. If you don't design around sort of image lifecycle, update cadence, host consistency, monitoring and cost visibility from the beginning, the service will slowly drift. Images become inconsistent, remediation effort increases, and the cost of keeping the environment healthy grows over time. So something like Nerdio pays for itself, right? And this is why good AVD design is not just technical, right? It's operational by nature. You should be thinking early about how the environment will be monitored, how image updates will be rolled out safely, how scaling logic will be reviewed and adjusted, and how cost anomalies will be detected before they become a pattern. Those things are not part of the design conversation, and they become reactive problems after go live. Look, again, we're talking about thousands of users here, right? Reactive operations are expensive, right? Predictable operations are what make a cloud desktop service sustainable. Look, if you take one thing away from this video, it should be that designing AVD for thousands of users is not about choosing a few components and hoping the best practices carry the rest. It's about aligning host pool structure, density assumptions, scaling logic, profile architecture, identity design, networking behavior, and operational management. It's a big list, right? So that the platform behaves predictably as a service. This is why enterprise AVD designs feel so different from smaller environments. At low scale, you can hide poor assumptions behind excessive capacity. At higher scale, poor assumptions become visible through cost, inconsistency, and operational pain. And those issues almost always trace back to design. So in my next video, I'm actually going to break down Windows 365 versus AVD properly. Not at a market level, but from sort of perspective of cost, control, architecture, and where each one actually fits. If there's a specific part of AVD architecture you want me to actually go deeper on after that, put it in the comments and I'll build it into, another video. Thanks for watching. Do not forget to smash that subscribe button and I'll see you on the next one.